other than it's just different formula now that we're using.
Yeah.
But everything else seemed pretty similar.
Yeah.
Okay, homework. Okay. I'm opening it up.
I need to go. Are you done?
All right. So you guys want to just go right into the quiz then?
Yeah.
Okay.
Okay.
So group meeting, lesson 14. In an ANOVA hypothesis test, we reject HO when there is sufficient evidence to indicate at least one mean is different from the others. That's true.
Yeah. Are you in, Phil? Your test?
Yeah. Yeah. Sorry, I'm not very talkative, so I just kind of.
That's okay. Okay. What requirements need to be checked when performing an ANOVA hypothesis test?
So there's 3 instead of the 2, and the only difference is, well, so we know all sample means are all positive. We know that has to be above 0. Data is in
that's something too. Yeah.
Variances are equal in each group. Yes, that's right, right?
But it only says none of the above are B and C.
Yeah.
So it must be B and C. Because we know.
Oh, it doesn't. No. Wait, but I think it does have to be. Let me see. Let me go back to my requirements. I have the notes here. Because I do think it has to be. Let's see.
I've got it right here too. Okay.
All samples from the simple random samples. All samples are independent. The populations have same variances. Check if the largest standard deviation is no more than 4 times the smallest standard deviation. And the data are normally distributed for each group.
So it's B and C.
So it's got to be B and C then.
Yeah, because you just said those exactly. Those variance
so the only one.
Each group.
Yeah.
So sample means are all positive is not one.
No, but it's not a requirement, but I remember reading that somewhere.
Yeah, I do too. Let me see.
But it can't be none of the above. So it's got to be B and C then.
Yeah.
Because we know for sure it's normally distributed and the variances are equal. Okay.
I know I wrote that down too, but I can't find it.
Maybe that was just talking about when you're on the graph, which I wanted to ask you guys that. So, you know, on all of the other hypothesis testings that we do, we can double check it on the applet.
Mm-hmm.
How do we have an applet, or how do you look at that?
You can't because it's just a normal probability applet, so.
And we
Yeah.
Okay. To check if each group is normally distributed, do the following. So construct a scatter plot in the data in each group. Construct a histogram or construct a QQ. They were always QQ.
QQ.
Yeah, I think it was the QQ plot.
For this one anyway. They didn't do histogram, but they did a box plot. I'm not really sure what a scatter plot is, so.
Scatter plot's different, so we haven't. Yeah.
We haven't really worked with that.
No, we haven't. But you know, they did do a histogram for like sometimes it was either a box plot or a histogram too.
They did on that one. They did on one example. That's right. But it was so. That histogram is almost impossible to read. I don't like reading those.
I don't either.
Yes.
I don't like the histogram, and I don't know how to do the box plot. So I'm like.
I was going to ask him about that too, because we don't in SRSS. There's a link for it, but there isn't
there? Oh.
in the Excel. But there's not in the Excel, so I wanted to see if there was a different app or tool or something that we could access. I couldn't find anything in the homework or in the textbook, but so I wanted to ask about that.
Yeah, I don't see anything.
In the SR, is that what it's called? SRSS programs? Because
Yeah.
those for he was using them for the tutorials, for the homework, for the chapter homework, or the chapter examples, and he kept popping them up as just another link. So it must be included in the SRSS files, but not in the Excel. Anyway. Okay, we assume the variance in each group is the same if the following happens. So the largest, I wrote this down, largest.
It's 2 times, I think.
Times the smallest.
The largest sample mean is less than 2 times the smallest sample mean. I think that's the right answer. Because the standard deviation is, I think, 4 times.
Yes.
Is that right?
I get the two mixed up.
Yeah, let me make sure. I know I've written this down a few times, so let me just...
I do too, and
I wrote it down again on the next page. It says the rule is that the largest variance is not 4 times the smallest variance, then we will conclude the variances are equal.
Or the largest variance is 2 times.
So I think the standard deviation is going to be 2 times. I'm trying to remember. I might have to go to the actual textbook.
Was one that I actually had it down to ask because in the tutorial for the homework assignment or the preparation assignment, you know how they go through each question? The second question, as he was writing it down on the board, so if you go to the answer key, it says the rule is if the largest variance is not 4 times the smallest variance, then we will conclude that the variances are equal.
Yeah, I've got that written down.
Then when he was writing it down, he did a different formula. He said that the largest sample variable is less than 2 times.
Yeah, there's
well, I didn't get it.
Either the standard deviation is 2 times or it's 4 times, and the variance is 2 times or 4 times. So, okay, in my homework assignment, the variances are equal. The largest variance is not 4 times more. So I think it's the 4 times.
The largest variance is less than 4 times the smallest.
Smallest variance. We can check the textbook to make sure.
The largest variance is not actually.
I'm going to get into the textbook really quick.
Maybe that's the trick right there. Because it didn't say that the largest variance is less than 4 times. It just said it's not 4 times.
I have it right here. It says if the largest variance is not 4 times as big as the smallest variance, we will conclude that the population variances are close enough that we can assume the variances are all equal.
Thanks. So then maybe it is because when he was doing the homework problems, he gave a new formula, or at least it wasn't in the homework, and he said the largest variance is less than 2 times the small variance. Is less than, and that's exactly what the bottom one says. And do you know what I mean? Like the catch being, the rule is that the largest variance is not 4 times the smallest. It doesn't say less than. It says it's not. Does that make sense? So I'm leaning towards the largest sample mean. So go into the homework, the video tutorials for this lesson. And if you click on problem 2, or actually before you even click on, he has the equation on the board without even, do you know what I mean?
Okay, so the options that we have for this one are the sample variance for each group is smaller than the sample mean, which is not that one. The largest variance is less than 4 times the smallest variance, which I think it's that one. The largest sample mean is less than 2 times the smallest sample mean, and each group has the same sample size.
I think it's the third one, only because it doesn't say that it's less than, it just says that it's not 4 times. So that would mean it has to be at least 4 times or more. Does that make sense?
But the third one is the largest sample mean is less than 2 times the smallest sample mean.
Right. So then go on, and this is why I'm thinking that. So go on to your video tutorials for this lesson.
Mm-hmm.
And then see before you even play it, do you see the formula he has in the background? That S means the largest sample variance is less than 2 times the smallest sample variance. And that's what he used through the whole...
I think that's why I had it written down wrong, but I'm confused because the textbook and all the homework stuff was 4 times.
Yeah, and the first thing it says is if the largest variance is at least 4 times as big as the smallest variance, we conclude the population variances are not equal. So it has to be at least 4 times.
Or more, right. So it's not less than, so it's got to be the third.
Well, see, and that's why I think it's the second one, is because if it has to be at least 4 times or more. But if it's not 4 times or more, then it has to be less than 4 times as much for it to happen. Is what I don't know. That's why it's confusing me too.
Well, but so it's saying that the largest variance has to be at least 4 times the smallest, not less than 4 times the smallest.
Yeah, but that's to be not equal. And in this one it says the variance is less than 4 times the smallest variance to be equal.
Mm-hmm.
We assume the variance in each group is the same if the largest variance is less than 4 times the smallest. The largest sample mean. This is one that we're going to have to go back and talk about, because it says in both where we have basically 2 correct answers here is what it seems like. Let's come back to this one. And maybe it will make us pick one. Okay. Are you guys okay with that?
In the textbook it says for the variances, it says the rule we will use is if the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal. So it says less than right in the description of the textbook.
Okay. Let's pick less than then.
4 times. I think that's going to be the right answer. I don't know why his videos did the 2 times, and that threw me off. But he has been wrong. That video they've caught him being wrong before. So.
Okay. Well, let's go by the textbook, and then if we get it wrong,
we can argue it. Yeah.
Well, definitely. Okay. So.
Okay, an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between pairs of samples. If there are 3 samples, there are 3 pairs, 1 and 2, 1 through 3, 2 through 3. How many pairs are there when there are 4 samples? What?
No, this one I always have to just work out by hand. So if there are 4 samples, how many different pairs are there? Right?
I think there's 6.
There's going to be 1, 2, 1, 3, 1, 4. And then there's going to be 2, 1.
I'm not really sure what this is asking. I'm sorry.
2, 3.
So when we have 3. Okay, when there's 3 samples, you have to compare each sample to each other.
Right.
So you have to compare sample 1 with sample 2. You have to compare sample 1 with sample 3. And you have to compare sample 2 with sample 3.
Okay.
So if you throw in an additional sample, how many more combinations are there going to be? So you're going to have those original 3. You're going to have to add 1 and 4. You're going to have to add 2 and 4, and you're going to have to add 3 and 4. And I think that's all you have to do.
Yeah, I think you're right. I think there's 6.
I think that there's 6.
Oh, but can you don't have to do like 2 to 1, 2 to, well, you don't have to do that again. 2 to 3,
2 to 3 is already there.
2 to 4.
2 to 4 is a new one.
Yeah, that's
Okay.
a good one.
And then 3 to 4.
That's a new one.
Because we already have 3 to 1.
So yeah, I think that's 6. And then 4 to, we don't have to do 4 to 4. You don't have to do 4 to 2 or 4 to 1 because we've already got those. Okay, so yeah, I think it's 6.
Yeah, me too. Okay. Oh, do we have to pull this up again?
Oh,
Do
yeah.
the soccer shoes.
Soccer shoes, wonderful.
We all groan and mumble and like, ah, he's dirty, rotten. I don't want to pull it up. Okay, so we need quantitative features.
Sorry, I didn't have any of this pulled up, so it's going to take me a minute.
Yeah, I didn't either.
I didn't either. I have the inference and stuff set up, but I didn't bring up any.
I don't even have that. It won't take long. So with that, the other one that we were just caught on, maybe what they were emphasizing is the rule of thumb point or whatever, as compared to there are other ways of doing it, but okay. It's gonna take me a minute.
I just want the data files. There we go. So we're looking for which one? Soccer shoes.
Sometimes my copy and paste doesn't respond.
Yeah, I had a hard time copying. Like you go back and it's still highlighted, and I have to release.
Yeah, that's what I'm having a problem with.
My husband said just press escape when you get back to the.
Oh, that's a good idea.
And that's worked for me since yesterday. Honey, I'm on a conference call. Okay, put that away. We're dog sitting, and I guess he just chewed up a block or something.
Oh no!
My son's traumatized.
So we have to put all of the info in except for the socks.
Yes. No, socks too. It's another category.
Yeah.
We just have to put it in a different variable.
Yeah, in variable 6, is it?
It's the last one, yeah. Okay, I'm just about got everything entered. Okay. Entered, yay! If I have to go through and make a histogram for each one of these, I'm gonna.
I hope not.
I'm not gonna be very happy, but.
Wait, what? How come I only have one? Oh, crap.
What
Never
happened?
mind. I put all of the data in one thing, and I forgot to separate them into different categories.
Oh.
Clear content. Clear content. Okay. A.
Okay, so we're supposed to put it all in and then observe that the p-value is 0.0809, and then we're supposed to remove the SOX data and then figure out what the p-value is. So let's make sure that it's right. Yeah, it's right. So I'm going to remove that. Clear contents.
Okay, what were you saying? Sorry.
Okay, for this first question, it's wanting us to observe once all the data is in that the p-value is 0.0809, and then it says remove the SOX data, which is the last column, and then it says what is the p-value rounded to the nearest 3 decimal places?
0.081. Is that what you're getting?
With all the data in, yes, it's 0.0809.
Yeah.
And then they want you to remove that. So clear contents on that last column, which is the SOX column, and then we need to figure out the p-value, which I get 0.309, but we'll see what you guys get.
That's what
exactly
I
what I got.
Okay. So it says the p-value always goes up when only one group is removed compared to the p-value when all 6 samples are included.
They talk about that anymore?
I have no idea. That's not something I don't think they brought up at all.
Yeah, let's look at the book real quick. Okay.
Maybe if we take different columns and see what happens, I don't know.
Okay.
I just removed column A and it went up again.
Okay. But is that going to be the same for every single data? Like, you know?
That's what I don't know. I'm looking in the book just to see if it says anything.
Oh, I cleared variable 5 and it went down.
Really? Okay, let's see.
Yeah, I don't know if you're working today or what do you need to know? I'll send back and
Okay, find the p-value.
Yeah, it goes down if you do variable 5, so that can't be right.
Well, but it just asks the p-value always goes up when only one group is removed compared to the p-value when all 6 samples are included. So, this only applies when you remove the 6th sample.
Oh.
Does that make sense?
Well, so it would be false because, right?
Well, no, just judging by removing the 6th sample, it's true because it did go up. It went from the 0.0809 to the 0.309.
But it doesn't it doesn't specify the 6 that says the p-value always goes up when only one group is removed.
Oh.
Compared to the p-value when all 6 samples are included.
Okay, so I'm gonna put my variable 6 back in and then remove another one.
Yeah, I mean when I put it back in and removed section 5 like you said, it went down.
It went down. Yeah.
Yeah, but let me just move it over. Let me move that over and see, like that one column over, and see if that makes a difference. Because I don't know if it's, you know.
So I get you.
I'm going to move column 6 over to column 5. Just see if that makes a difference. Okay.
Yeah.
Your content. No, it's still 0.05, so it went down.
So so I'm just randomly picking ones, and if I randomly picked 5 to remove.
Uh-huh.
and it went down. I randomly picked, or not randomly, but then I picked column 2
Uh-huh.
and deleted that, and it went down too.
Oh, okay.
I don't have the
So
socks,
some go down and some go up.
but
Yeah,
I don't have the socks in though. Does that make a difference?
Well, I do have socks. I have socks in variable. I moved it to variable 5, but and then just removed cleared content for variable 5, and so I think it's false.
So when I do too.
this is a great one.
It doesn't. Yeah, it's false because variable 2 and variable 5, if you delete those, they go down. If all the other ones, it keeps going up.
Okay.
So it's got to be false.
Well, that's our next question. What's the highest p-value when only one group is removed?
Oh, well, let's go back then. I think
Okay.
So we're only removing 1 this time. Okay. I'm going to make a little...
If you remove variable 3, it's 0.447 or 0.448.
If you remove variable 2, it's 0.052. What did you say it was for variable 3?
0.448.
For which one?
Variable 3, if you remove variable 3.
Yeah,
Okay.
it's 0.448.
If we remove the first variable, it's 0.060.
Yeah, it's not that one.
If we remove the fourth variable.
It's not the second one.
Wait.
It's not the fourth one. It's not the fifth one.
I think it's the sixth one.
No, because the variable was at 3 was like 0.4, so it was the largest one.
Oh yeah, you're right.
Is it variable 3? Let's see.
Yeah, it is. 0.448.
0.448. Okay. Okay, when all 6 samples are used, what is the minimum smallest variance? Oh gosh.
What is the minimal? Okay, we just gotta.
So we got to put everything back in. Okay, which I think I have it.
Is this in the where it says ANOVA test the source of variation, so like between groups and the sum of the squares? Is that what it's talking about? Because I don't.
I think.
I think it's just like descriptive statistics. The smallest variance out of variable 1 through 6.
That's what I'm thinking.
Yeah.
Oh.
So it'd be variable 1, or no, variable 3 again.
It's variable 3, 27.208. Is that right?
Yep.
Where? I'm not seeing that number.
So
Okay.
Descriptive statistics data.
Yeah.
Just look under the variance column, and it's the smallest one.
Well, I don't have a variance column.
Are you on ANOVA in that program? Yeah.
Yep.
It's to the right of the top. It's the top right. Descriptive statistics. It's got the mean, the standard deviation, the variance, and the n.
I don't have that. I just have the standard deviation in the n.
Really?
Yeah, I don't have a variance.
You might want to, when the next time you open up the inference worksheet, make sure you go to the textbook and open the latest one, because maybe you just have an older version or something.
Yeah.
Well, I opened it from this week's notes from instructors.
Yeah, go to the homework page. Because he was saying at the very beginning of this class this semester, that the most updated versions will always be in the homework.
Okay.
So maybe you just have a slightly older version. I don't know.
That is so weird.
Yeah, just go to the textbook and to the get it right from that. But it should have like descriptive statistics, and then it's like, 4 columns, and then below it is the ANOVA test, which is like the source of variation, the sum of squares, the DF, the mean square, the F, and the p-value.
Okay, so I have that. Go to ANOVA. There we go. Now I got it.
Okay.
That's weird.
That is really weird.
Okay, so I guess instead of saving this from having to install it, and what is your guys' small variant?
The 27.208 is the smallest.
And your largest?
And the largest, I think, is going to be this 53.158.
That's what I think. That's what I have too.
Okay.
The test for equal variances is satisfied for the data. So equal variance.
That's if nothing is 4 times.
So
let's take a look at it. There's nothing that's 4 times as large, because I mean the smallest is 27.208 and the largest is 53.158.
20. Let me see if it's 27.
Yeah, it's not even 2 times as large, so there's no way.
But this. So 27.208 times 2 is, well, it's just slightly more. So yeah, let's say false.
And it has to be like 4 times as large, so it's false.
Yeah.
No, I was saying if they were switching the rule on us.
Yeah.
That 2 times.
It was 2 times, yeah. But it still doesn't even meet that, so.
It's still smaller. Okay, construct a Q. Oh no, seriously.
Okay. Do you guys want to split it up and do like,
Yeah.
2, 2, and 2? So.
Are we gonna have to do? Oh yeah, let's do that. So
okay, so do you want to do the column 1, 2, and I'll do 3, 4? Bill, you do 5, 6? Okay.
Sounds great. Where's the, how do I get the QQ plot thing?
It's in the quantitative descriptive program.
That's right. I knew that.
Copy. Paste. And you do have to sort it, so just to warn you.
I figured that out when I was trying to make the example.
I know.
I was like, what?
Okay. So my column 3 looks pretty normal.
Hold on, I'm still pulling mine up.
Okay.
Yeah.
Well, I'm going to check 4, but I'm just, it looks good. Let's see. I love it that we're all like, no! Now, if we can only have each other for, like, the homework test when they're going to make us do all 6.
Yeah, I don't know why. Your content. Copy.
Okay. So, all right, I'm done for mine, so just tell me when you guys are, but both of mine are normal.
So how did you sort yours though?
You just go under
Smallest to largest. You just go to data, sort, smallest to largest.
Yeah.
Okay, 1 is normal. Let's see if 2 is.
Mine kind of seems right skewed for number 5.
Okay, I'll take a look and double check it.
Yeah, please do, because I'm not the best at these.
That's okay. Okay, number 5.
Yeah.
No, I think that's pretty normal.
Oh, is it? Okay.
Yeah, it looks normal to me too.
But are you looking at the QQ plot?
Yeah.
Only because there was an example like this in the homework, in the reading,
Mhm.
and it was a little off like that, and he said that it was normal.
Yeah. Normal enough to go for it, yeah.
Yeah.
It kind of curves up at the bottom, is that what you're seeing? And then it comes back, and then it's just like, yeah. But it's pretty close to the dotted line.
And I would say 6 is the same. I mean, it does have one little finger there that's kind of further away, but did you say 6 was normal to you? Blue?
I'm checking 6 now. Data, sort, smallest to largest. Yeah, 6 is a little bit more skewy, but it still looks like it's pretty normal. Like it starts off at the bottom in the right spot and ends up in the right spot. It does go off a little bit.
Okay, so let's call it normal.
Sounds good to me.
Okay.
Okay, they're approximately normal. Yeah, true. Okay, the test statistic for an ANOVA hypothesis test is an F statistic. P-value, the area to the right or left of the...
It's the right.
So how do you figure that out?
Well, I always thought that it was just like, well, because in the reading it showed like the right part of the normal applet, and I thought it was always right.
Uh-huh.
It's always going to be that right tail.
Yeah, they said it's always going to be the right tail, and they'll never divide it.
That's what the it has to be greater than 0 thing is.
Yeah.
But that's what.
Oh, okay.
So it's always going to be right, because it's always going to be greater than 0.
Mm-hmm.
Okay. All right.
So is there any that we want to go back over?
No, I think we got them.
Okay. So we got true for or false for 13, true for 14, right for 15, right?
Yeah.
Okay. All right. Are we ready to submit?
I submitted.
I'm submitting.
We got a 94.
Oh, okay.
You're wrong.
We
which one?
We missed 13. That was true.
The test equal of variances is satisfied for these data.
But it's not. See, then that went back to that whole, because the 2 times it was really close to it. It was slightly smaller, but only by like a couple hundredths of a point. So we need to ask him about that one, because 4 times it definitely was not, but 2 times it was really close to it.
Oh wait, you know what? But it was true, you guys, because we were just looking at this question wrong. I'm surprised I didn't even catch that. Yeah, no, I mean, we're trying to check to see if they're equal, and unless they're 4 times more, then they are equal. So it would have been true. I don't know why we marked false.
Oh, yeah.
That was just not.
So unless it's four. Wait, say that again. What were you saying?
Okay, so we were looking to see if they were satisfied. So we were checking to see if anything was larger than 4, because if it was larger than 4 times between the smallest and largest, then it would not be equal, and it wouldn't be satisfied. And it was. There was no large number, 4 times or more, so it would have been true. I don't know why I didn't even catch that.
Okay. And we should have caught it too, because if the QQ plots are approximately normal, then the
Yes.
would have been
Yeah.
the same or close enough.
Yeah.
Okay.
But we were right on the 4 times one. That was earlier, so that was correct.
Okay, that's good.
Yeah.
Okay.
So we just have, it's just hard. You have to be so careful in reading these questions because they get so tricky in their language sometimes.
But I would much rather learn to catch those little phrasing things now than in the exam.
Yeah. Well, I didn't do so great on my first exam because of stupid little things like that. So I'm just like.
Well, this time they have us actually do a study group meeting. So we still meet on Thursday, but it's all study for the exam.
Oh.
So if you guys have concepts or things that you know are still just not sticking, write them down so that we can try and help each other figure out a way.
For me, it's like everything seems so like straightforward, and then you get in there. I think the only thing I would love to go back over is differentiating between like what is a 2-paired, what is a 1-paired. Like when they give the examples, and I don't get those at all, and I don't know how you could actually prepare for that. But they give you different examples and say, okay, is this like a T test, a Z test, or an F test, or I don't know. So that throws me. I'm like, I don't know. So.
On that little flow chart, you know how you gave it that flow chart?
Yes. Yeah.
One of the things because I didn't catch that at first too, so I started just Googling whatever I could find outside of the class.
Yeah.
And or just further definitions, so it would stick better. And the thing, he actually has it written in there, but for some reason I had missed it. But if it has the standard deviation, it is always going to be a Z test. If it does not have the standard deviation, it's never going to be the Z test. It will always be the test. And then as far as the paired,
I guess if we're finding a difference, then it's the paired.
Right.
And then
Well, and I think of it too as if there's any connection, if there's any shared description or connection between the groups, then it's always going to be paired. Otherwise, they'll be independent.
Okay.
So like the airplane one, the reason why that was paired was because it was the same flight. It was just at a different time.
Okay.
And then the independents, they would just be completely different, like the soccer shoes.
Okay.
They're all soccer shoes, but they're totally. Picking one soccer shoe is not going to help describe or define what the second soccer shoe is going to be.
Right. Yeah, because I got that one wrong on the last quiz or whatever about the husbands and wife one, and I was like, I thought they were.
You can't, since they wanted you to do couples.
Yes.
If you pick the man, then you have to have his wife.
Yeah, that makes sense, but that didn't even compute in my brain.
Right.
Thinking about that, so. Anyways. That's the only thing, but everything else I'm like, it's just mainly stupid little mistakes that, cost me the question, so.
What helped last time when I was studying for the exam, and I did good on the last one, I went through and I copied all of our group meeting quizzes and my homework quizzes, and I literally went through each one of the problems that I'd gotten wrong, I mean, I quickly read through all of the ones all of them, but then the ones that I got wrong, I went through them again to make sure that I could get them right. And I think that helped a lot. I mean, it was a little bit, it was a little bit time consuming, but I think overall it really paid off.
Yeah, I might do that. I do want to not get a bad grade on this one. I want to get a better. It's so frustrating.
Yeah, and if you get a good grade, it'll pop up your overall score a lot because our quizzes or these exams are worth, it was like 60% of our grade or something crazy.
Yeah, it's pretty heavily weighted. Yep.
So if you do well on this, then it'll pop your grade back up again too.
I hope so. I haven't been doing as well with the individual quizzes. That's what makes me nervous. I'm like, oh.
Yeah, but those are in the long run, those are worth so little. It's better to miss it now than definitely in the exam.
Yeah.
Although, they help. When we get hundreds, I notice my point, goes up a little bit. But
yeah.
Anyway, well, so we'll just plan on, meeting again Thursday. They actually have. I was just looking at the assignment before today, this morning, but there's actually a group quiz that we have to do for the exam prep. I don't know how extensive it is. I didn't want to open it up, but
we had one last time too, didn't we, Phil? That we went through.
I can't remember. I think so.
Yeah, we had to go through something together, but it took a long time. It was like 33 questions, and we were like, ah. So.
Oh, I do remember that. I remember something being.
You weren't able to join us, but you watched it later. I remember, right?
Oh yeah, that's right.
And
that's right. I remember.
We got kind of tired towards the end, and so we just started going, okay, let's get done. And so, I don't think we did great, but I don't think we did bad. Like we just got like a couple wrong. But.
Yeah,
Which is frustrating when you do the prep and you get them that you do that okay, and then you take the actual test and you don't do as great. So I was like, ah.
So we'll want to plan a little more time then, if it's because that was a long meeting. It was close to like an hour and a half or more. So
yeah.
So yeah, plan a little bit longer next Thursday then.
Okay.
All right.
Sounds good, y'all. Okay. We'll see you guys Thursday.
Yep, sounds good. Bye-bye.
Bye-bye.